Alright, so our last example of section 6.2 on this first page had gotten cut off in last video, so I'll finish it up now. What we were looking at is we had pulled out a GCF of 16y and put it out front. Dividing it out of each of these three terms resulted in a y squared minus 2y minus 3, which we noticed is that basic form where we have a variable squared term, a single variable term in the middle, squared term, single variable, and then constant on the end. So then we could solve what was left inside the parenthesis as just your regular x squared plus bx plus c. So, taking a look at that, we need to find the two numbers that add to give us negative 2, that also multiply to give us the negative 3. Looking at those two numbers, or those two combinations, we could come up with the numbers negative 3 and 1. Negative 3 plus 1 gives us the negative 2 for the middle term coefficient. Negative 3 times 1 gives us the negative 3, the constant on the end. So, we go ahead and we plug in those two values, y minus 3 and y plus 1, because those were our two values we found, the two factors. However, that GCF we pulled out at the beginning of the problem, the 16y, we do need that out front in our final answer. So that 16y will go out front when you do write your complete final answer. Alright, so that finishes up trinomials of the form x squared plus bx plus c when there is no number in front of x squared, or if you can pull out a GCF so that there is no number out in front. Now we're going to look at trinomials of the form ax squared plus bx plus c. When you do have a coefficient in front of your x squared term, you do have a number out there. Okay, so taking this, we have specifically what I just said. This is when we have a coefficient in front of the x squared term, a coefficient other than 1. Okay, and what we're going to use is a method we call divide and slide. Now there's a way to handle these using grouping, a process where we set up the equation, we turn it into 4 terms, and then use the grouping method. However, that method's a little more tricky. It takes a little longer, and once I learned this divide and slide and taught it to students, I found they're a lot more successful with it. So, if you already know that other method and really love doing it that way and are set on doing it that way, by all means, do your problems that way. I believe that's how my math lab will explain the problems. But if you find that you think this way is easier, just use this divide and slide method. So, when we have a number in front of our x squared term, and here we have 12x squared minus 5x minus 2, okay, and we can't divide out a GCF, we can't get rid of this 12 because 12 won't go into 5 and 2. We can't pull out the GCF. We have to approach this a little bit differently. Okay? So the first thing is what we do is we find the factors of not just the negative 2, we find the factors of the product 12 times negative 2. We do multiply our a times our c value. So we find the factors of a times c that also have to sum, in other words, add to equal our middle term, the b value. So same idea where we're looking for two numbers that multiply to give us something and add to give us something else. It's just we don't just consider the number on the end now, the c value, we have to multiply a times c. Okay? I'll show you why that's the case here in a second. So in our problem, we have our a value, b value, c value. So a times c, in this case, is going to be 12 times a negative 2, which is going to give us a negative 24. So we need two numbers that multiply to give us that. But then we want those same two numbers to add to give us our b value, which is middle term, the x term's coefficient, negative 5. Okay. So two numbers that multiply to give us negative 24, that also add to give us negative 5. Those two numbers are going to be negative 8 and a positive 3. Multiplying them, we do get a negative 24. And adding them, we get the negative 5 we want. Okay. So once again, the two numbers that are important to take away from this are the negative 8 and the positive 3. Alright, now what we do with those two factors, we still can, the next step is still the same. Place the two factors in parentheses with our variable. Okay, most of the time our variable we're dealing with is x, so we can set up parentheses with x and those two values, negative 8 and 3. So x minus 8 because we had a negative 8, and x plus 3 because we had a positive 3. Here's where the problem is different. Because right now, if we were to FOIL this out, multiply these two binomials out to check, we're going to get an x times x to give us an x squared, but we have a 12x squared. It's not going to match up. The negative 8x and the 3x will combine to give us a negative 5x in the middle, but also this negative 8 and times 3 won't give us a negative 2 on the end anyways. So we're not done here. We have x and x to get us x squared. We need a 12x squared. So we're going to have to find a certain combination that will give us that, but there's actually a direct way to find that combination, and what we do is we divide. That's why we call this divide and slide. We divide the two factors we had in our parenthesis, we divide them by our a value. Okay. Well, here, not just divide anything by the a value. We want to divide our two factors by that a value. Okay. And in our original problem, our a value is that 12. So we come underneath the minus 8 factor, divide by 12, come underneath the positive 3 factor, divide by 12. Okay. Next, we want to reduce the fractions, if possible. Okay. And then if we have any remaining denominators, if they don't reduce into whole numbers, then we want to reduce the fractions and slide any remaining denominators. Okay. So, reducing our fractions here will give us x minus 4 goes into 8 2 times, 4 goes into 12 3 times, so that will reduce to a minus 2/3. And then 3 goes into 3 1 time, 3 goes into 12 4 times, so that reduces to 1/4. But we have to, now that we're fully reduced, we have these two remaining denominators, we slide them. So here's the slide portion of divide and slide. We take the denominator and we slide it out in front of x, giving us a 3x minus 2 and a 4x plus 1. And that 3x and that 4x, when we multiply, will give us the 12x squared we want. So again, slide the 3 out front of the x, it becomes 3x minus, and just keep the numerator 2. Other fraction as well, slide the 4 out front of the x, keep the numerator plus 1. Okay. And we could take that result and FOIL it to check. 3x times 4x will give us 12x squared. 3x times 1 is 3x. Negative 2 times 4x will be negative 8x. So 3x minus 8x will give us minus 5x in the middle. and then negative 2 times 1 will give us the negative 2. So again, we could FOIL just like always to check and make sure we have the correct answer. Alright, and that is the divide and slide method. Divide because you're dividing by the a value, and then sliding because if you still have fractions when you reduce, you have to slide those denominators out front. Okay, let's look at another example. Let's say we're asked to factor the expression negative 3x squared plus 16x plus 12. So, same idea, we have a number in front of our x squared, and we can't divide that 3 out as a GCF because 3 won't go into 16, even though it will go into 12. So what we do have to do a little bit differently in this problem, however, is we don't want our x squared term to be negative. So if we can, right off the bat, factor out a negative 1 GCF in order to make our x squared term positive. Okay. So what that's going to look like is if we pull out a negative 1, it's just going to change the signs. It's going to make it a positive 3x squared, a minus 16x, and a minus 12. Now we can do the whole a times c method and divide and slide. So looking at just what's in the parentheses, a times c is going to be a 3 times negative 12. Gives us negative 36. So we need to find two numbers that multiply to give us that. Then our b value is the negative 16. So we need two numbers. Not only do they multiply to give us the negative 36, but they have to add to give us this negative 16. So after thinking about those, the two numbers we need are going to be negative 18 and a positive 2. They multiply to give you the negative 36 we need. They add to give us the negative 16 we need. Okay? So negative 18 and positive 2. So let's use those to write our expression. So x minus the 18, x plus the 2. Of course, that's not going to be the correct answer because that would give us an x squared when we multiplied. We need a negative 3x squared. So now we're going to deal with our divide and slide method. So again, at this point, we divide by the a value, which in this case our a value was 3. So we divide the minus 18 by 3, we divide the 2 by 3. Okay. So we want to, at this point then, reduce the fractions if possible, and slide any denominators out front. So So 18 divided by 3 gives us 6. So we don't have to do any sliding there because it reduced to a whole number. But 2/3 won't reduce. We still have a fraction. So we have to slide that denominator of 3 out front of the x. Okay. So then that's going to give us x minus 6 and 3x plus 2. Okay. So that's great. That should be our answer, right? If we were to FOIL this, what would we get? X times 3x would give us 3x squared. But we have a negative 3x squared. Don't forget, we pulled out that GCF of negative 1 to begin with. Okay. So we can't forget about that. So actually, if we remember that -1 we had pulled out front, this expression is going to equal -1 out front, x minus 6, 3x plus 2. Okay. And I believe my math lab will accept that answer. I would always accept that answer on a test. However, you also could decide then either of the two parentheses to distribute that -1 into. If we distributed the -1 into the first parenthesis, that'd make that x become a -x and the -6 become a +6, a +6. And then it wouldn't affect the second parenthesis. Or you could choose to distribute it into the second parenthesis. So it'd keep x plus 6 the same and then make a 3x plus 2 become a -3x minus 2. So either of these three ways are correct forms. Okay. Typically, I like to put the -1 out front since we did that from the start. And like I said, I do believe my math lab would accept that method, or accept that answer. Okay. So that's how we handle when we have a number out in front of our x squared. I do want to give you one alternative method because you could use what I'm going to show you for anything. So here's the idea. We know when we factor a trinomial, pretty much we're going to get this double parenthesis as an answer. So we're going to have something plus something else in one parenthesis, a binomial, and we're going to have another binomial in the other parenthesis. Okay. Some things we know about these though, just by factoring these. Hopefully some of these tendencies, these kind of patterns are showing. Whatever our first term is here and first term is here, I'm calling them A and C, they have to multiply to give us the lead term in our original trinomial, 3x squared. So we know A times C has to give us 3x squared, and we know that the last two terms, the term here and term here, the B and the D, those have to multiply to give us this number on the end. So in this case, whatever those are would have to multiply to give us a 2. It's finding the right combination that then give you the middle term that's correct, the -5x. So in our example, when we have prime numbers as our coefficient of the x squared term and a prime number as our constant, it actually makes this method nice because you have a limited amount of options. Okay? We can start thinking about what would your possibilities be. Well, first of all, we know the first term here times this first term has to give us 3x squared. There's only one way we can multiply to get 3x squared. That's going to be a 3x and an x. Okay. And then one way that we could multiply to get 2 would be a +2 and a +1. So there's one possibility. Well, another possibility, again, could be 3x times x to get 3x squared. Another way we could multiply to get 2 would be if we had the positive 1 there and the +2 there, just reversing the 1 and the 2. Okay, that's going to give you a different answer if you FOIL that out. There are two other factors of 2, though, we haven't considered yet. Again, we could have 3x times x, because it has to give us 3x squared, and that's the only way to do it. But we could have a -2 here and times a -1, because that will multiply to give us the +2. And then one last option would just be reversing where the -2 and the -1 are. So 3x minus 1 and then x minus 2. Okay. So 4 possibilities. How do we know which one is correct? Well, we have to FOIL them out, and if you can do that in your head or kind of do that quickly, it makes this method a decent way to approach these factoring trinomial problems. This is going to end up being the correct one. I'll just kind of save us some trouble. If we FOIL it out, 3x times x, 3x squared, 3x times -1 minus 3x, -2 times x minus 2x, -2 times -1 plus 5. Or sorry, plus 2. We already knew each of these are going to give us the correct first and last term. Do the two middle terms to combine to give us the -5x? They do. Okay. So because we get the expression we started with, we knew that was the correct factoring. So it's one other way to approach some of these factoring problems. If you're good with multiplying and adding things in your head, then this would be a decent method for you to use. Otherwise, I would just use the divide and slide on all of them when you have a number in front of x squared. That is it for 6.2.